All right. Neat, 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 neat. We're back. And a trusty little stopwatch here so I know how long the video is. You got your host, the Sissy, with Lightbulbs 3. And let's start off with a simulation. Not to be confused with stimulation. There's a big difference. So, we are going to this time go over Lightbulbs 3, but we're going to have a little twist on things today because we already learned about light bulbs from episodes 101 and 102, and this is Lightbulbs 103, but we're going to have a twist with that because in this one it's also going to be it's going to be about relays. And what does a relay do? Because what we are going to do is we're going to use a relay to turn on a light bulb. And so that's why I'm still calling it Lightbulbs 103. But we're going to use a relay to do it. What do you think about that? So let's go ahead and get rid of this gizmo. And what we're going to do is, okay, so here we have our 120 volt source coming from outside. And we're going to go ahead and put, hey, remember what a ground is, right? Well, we got a ground. Let's ground this side of the AC power. And we're going to ground our little light bulb. And we got a little extra treat today. We're going to have an extra random fireworks generator up here. We're going to put a ground on that as well. Because when we trip the light bulb, we're also going to trip the fireworks. And it has a question mark on it. So it's going to keep changing and go random. And you know what else we should probably do? We should put in a robot also to make things a little fun. Or maybe something like a laser generator or Jacob's ladder. Let's do Jacob's ladder. Matter of fact, let's just try Jacob's ladder right off the bat and watch what it does. We're going to leave it in the circuit to let us know that circuit is flowing. So we're going to put our Jacob's ladder right there. And we are going to get rid of this wire. And we're going to put a new wire. That's a four-letter word, wire. So now we have our Jacob's ladder. Let's just see what the Jacob's ladder does. Well, what is a Jacob's ladder? Well, I guess you could look it up. But it's basically a device that lets electricity flow, and it's a high voltage device. The voltage is beefed up a bit, and it's a show-off machine. So let's get our ground again. And let's see if we put our ground to our device, what it looks like. And simulate. So look what it's doing. It's got voltage. You've seen these in Frankenstein movies. And you can adjust in the parameters, you can adjust the type of curve it's got. And you can make it go higher and lower, and you could change its intensities around. And that kind of stuff, say. But anyway, we'll go ahead and get rid of our little toy here. Let's get out of simulation. And what I'm going to do is I'm going to show you how a relay works. And then I'm going to take you online and we're going to look at some pictures of relays and actually see one that actually functions. And you can see how easy a relay is to actually operate. There's really hardly anything to a relay, but it's very essential. And we're going to do all this just to turn on a light bulb. But we're not going to flip a switch directly to turn on the light bulb. We're going to have a relay. We're going to turn on a relay, and a relay is then going to turn on the light bulb. So down here, we have some relays. These are not a real good visual representation of a relay kind of, but it's not bad. If you want to see what that looks like in the 2D world, it looks like that. So basically here's what we have here. We have a coil of wire, and an amazing thing about a coil, it's absolutely unbelievable if you don't know it, but a coil of wire will become a magnet while voltage is applied to it. It actually will do that. It's a miracle in life. It's called an electromagnet. And when that electromagnet becomes a magnet, we're going to see what it does. It pulls in this switch. And that switch is then going to turn on. So we're going to actually go ahead out of 2D, back to 3D. And we are going to make a copy of this relay. And we're going to move it up to here. And we're just going to put it about right there. And I think we're going to twist this in a 90-degree angle to there. So our coil is here. That's our coil. This is our contacts. This set of contacts is going to be exactly like a switch. It is a switch. So if we go back to our, let's see, what were we at? We want to switch here, okay? This switch that we're so used to, I'm just going to set it here. It's not going to do anything. I'm just going to set it here for now. This switch here is exactly what this is. You see on top? See how those little terminals are right there? That is exactly what this is. The only difference is that we have to use our fingers to flip this switch. This one we don't. When there's any time there's a voltage across this coil, it will make a magnet out of the coil, and then it will automatically make this switch make contact. So what we're going to do is, we have a light bulb up here, and we have a little fun experimental toy up here. And we're going to go ahead now, and they have their grounds on it. But this time, we're going to wire the AC power directly into the relay instead, the relay contacts. So we're going to get rid of this wire, and we're going to do this. Oops. I want wires. It helps if you have wires. So we're going to go to there, and we're going to make it so it looks nice on the eyes, so you can see it nicely. Then we're going to have this come out and go up to here and go to here. There. So mind you, these two contacts will close and turn on the light when there is a voltage on the coil. So let's go ahead and put a voltage on that coil. So here we have DC voltage. It has to be DC. There's a difference there, but we don't care about that. We just want to know how a relay works. So we have like a battery or something, 12-volt battery, and there's no polarity. Doesn't matter if you put negative or positive. It's just a coil of wire. There's no special things that you have to know with that. So let's go back to our wire and put this terminal here and here. And then we're going to bring this one over to here, over there, and we put it to, we're now, I'll tell you what, let's just put this here. Hey, you know what? Let's actually make a copy of this switch. Let's get out of this. We'll make a copy of this, duplicate it. What we're going to do is, we're going to put another switch over here, just temporarily. And we're going to put it in line here. This is just for demonstration purposes. Something else would be making the voltage besides what we're doing with the switch. But this is just to show that we are going to apply the voltage with the switch. And when it does hit the coil, then it will pull in this contact. to let the AC power flow through to the light bulb. Okay, so now we need another piece of wire to go from here to here. So you can see now the coil is right across the battery, except the switch is in between. So let's go into the demonstration purposes and flip our switch, and let's watch what happens. The light comes on. Look at that. It goes right through the coil. I mean not the coil, not the coil. It goes through the contacts and turns on the light. So let's turn this back off. And just for fun here, let's add in a little bit of fun. And then we're going to go online. We'll take another piece of wire to see what happens when we do this. And we're going to add this extra device for fun in here. Now we're going to flip the switch, and let's rotate our screen down a little bit. And we're going to back out a little bit to watch our fireworks show. Hit the switch in simulation mode. Pretty cool. So think about this. We flipped a switch, and that switch turned on a relay. And that relay passed the current from the 120 power supply through and did all that for us by just flipping a switch. Now in real life, a voltage would be applied for a different reason. Maybe something's going on a different circuit, and all of a sudden, hey, well, we need that relay to pull in. So it would then be applying the voltage to the coil, and it would happen automatically, possibly not being done by a hand switch like this. But anyway, that's how a relay works. That's about as far as we need to go. But you also want to notice that there is another relay with more contacts on it, like this switch. Okay, so that switch, remember on episode 1, we could flip this switch either way. We could flip the switch to the right, to the left, to the right, and the center pin is the common. You notice it's always at least attached to this pin, and it swings this way or this way depending on which way you flip the switch. Anyway, that's enough of this. So now we'll just come back briefly at the end. So let's go ahead now, and we're going to go online and look at some pictures of a relay. We get a better grip of or understanding of how a relay really looks, and we're going to see actually how it. When you see how it looks, you'll go, oh, I see what you mean by a coil. So let's do that. A relay. Definition of a relay. It's a number of persons who relieve others on some work. It's a race between teams. Oh, no. Oh, you mean... Oh, I get you. Oh, here you go. It's an electromagnetic device or remote or automatic control that is actuated by variation in conditions of an electric current, and that operates in turn other devices such as switches in the same or a different circuit. So that's that's the Merriam-Webster dictionary definition of a relay. Okay. Boy, that doesn't tell you much, does it? You know what a relay really is? It's a coil of wire. I'm going to tell you what it really is. It's a coil of wire with a set of contacts on it, like a switch. And when electricity flows through the coil, it becomes a magnet. within the relay device, and that magnet pulls a piece of metal over, and that metal touches another piece of metal. So what it really is, if you're going to make it really simple, it's an electromagnetic switch. That's what it is. It's not all this other crap. It can be used as an automatic control that is actuated by variations and conditions of electric current. They're trying to, you know what they're doing here? Let me tell you what they're doing here. They're trying to sound big on words. No. A relay is a coil of wire. It's enclosed in a little square box, usually. It's a little coil of wire with a set of terminals, and when you put a voltage to that little coil of wire, it's about, maybe some relays can be the size of your thumb, and some a little bit bigger than that, but usually you could hold a relay in your hand really easily most of the time. And it's only the most basic of all relays is going to have 4 wires on it. That's the most basic, but most have at least 5. It's a coil of wire that becomes a magnet when you put voltage to it. And that coil of wire, when it becomes a magnet, it pulls in a piece of metal. And that piece of metal touches another piece of metal. And it can be used as a switch. It's really a very basic thing. Oh, it's a remote or automatic control that is actuated by various variations and conditions of electric circuit that operates in turn other devices. They make it sound way too complicated. But anyway, all right, and as far as relays go, we're going to look at some pictures of relays. That's when you hand the baton to somebody else in a race, right? Oh, that's a different kind of relay. Oh, we'll forget that. Oh, they're over here. These are relays. There's a relay. Relays. Now, see, they have terminals on them. The most basic relay of all is going to have pretty much 4 terminals, the most basic ones. And then, depending on the type of switch that you had, remember we were looking at switches in number 1. Remember the switch that had, you could throw it to the left and throw it to the right because it had a center pole in it. Well, that switch is the same thing as a relay. A relay is exactly that switch, except it is controlled by a voltage rather than your fingers. Okay? It's that simple. Usually, they can fit in the palm of your hand without a problem. You can see one with someone holding one right there in this picture. And a lot of times, they either have wires going to the relay, or they have a socket like this. So here's a brief description here. If you look off to the right, you can see how a relay actually works. Now, one interesting thing to know is there's something called a coil. You see this coil of wire here. Hey, look at the ground. Look, there's a ground. Now, the relay operates when current flows from the power source into the coil. It's a miraculous thing that happens with a coil. A coil of wire it sounds so basic. Doesn't it sound basic? Like, what is a coil of wire going to do? Literally, it's a coil of wire, and it has a little bit of insulation around it. So one piece of the coil cannot short out the others. It's insulated barely, with a coating or something to that effect. But when you take a coil of wire, if you have, see how it wraps around this iron core? The iron core gives it more ability to become a magnet. It's really so simple, it's almost stupid simple, but it works. So if you take a coil of wire and start wrapping it around something, like a pencil or whatever, and then you have two ends of the wire, right? Every wire has one end and it has a start and a beginning. You wrap it around, maybe you wrap it around, it might take you 10 minutes to make a coil. You just keep wrapping it around, wrapping it, starting at the bottom, wrapping it. You keep wrapping it around this in this case they use an iron core because it works more efficiently. You put voltage to it, the doggone thing will become a magnet. Isn't that amazing? Well, it will. That's called an electromagnet. Now, that's almost like almost sounds impossible, but that's one of the most basic electrical devices that we have. You know, you could talk for months about coils, but just basically that's what it is. Now, when it does become a magnet, there's a set of contacts, like for a switch, that is very nearby. And when that magnet is here and it becomes a magnet, it pulls on this piece of metal. And that what that tells me is it's time to squeeze my tea bag. So basically, what it does is up here, when this becomes a magnet, it pulls down this piece of metal, and all it does is make this metal touch this metal. And there is your contacts, just like a switch. See, they confuse it over here by adding all these extra wires. You don't necessarily need the power source to be tied into the coil. You don't need that. They should, for the sake of simplicity, they should not have that hooked up. It should be like this. This is more simple. Here's your coil, represented by this ziggy line here. Okay, and there's your switch. Look how simple that is. There's nothing to a relay. It's so simple. You could make one in your basement. Just take a coil of wire, and here's your contacts. So there's the electronic or electrical representation of a relay. And here is your contacts, just as if you were throwing the switch with your hand, except now you're applying a voltage to this thing instead of your fingers flipping the switch. That's all it is. That's it. All right, we'll go ahead and end this video, this portion of the video. And I'm back. What happened was I was sitting here in my area that I'm in, and something must have dropped from the ceiling and hit me on the back of the neck from up above. I don't know if it was a spider or what, but something tapped me, so it kind of distracted me for a second. All right, since I'm on this page, I wanted you to look at something that's even more clear. This one. If you look at this picture, now what just happened? All right, we'll get rid of this one. But anyway, this one over here, this is a good one. If you look at the top right hand where my mouse is, way over here, look what it's showing us. On this one, for what a coil does, it shows the coil and it shows north and south. And if you look at the video, it's actually showing the relay working. So you're applying a voltage, it's making a magnet with north and south, and it shows that when the switch is activated here, you see here like somebody's flipping a switch maybe, whatever, it becomes a magnet, and then what happens is the armature up here on this piece of metal moves and gets sucked down to become it's sucked down and goes to the magnet because it's supposed to, because it's metal and it's a ferrous metal. So when it does that, it's on this, it makes these contacts touch. Watch how they touch. That's all a relay is. It's so stupid. It's easy stupid. But they're everywhere in this world. They're everywhere. You wouldn't believe a coil of wire can become a magnet, but it can. And another one right here. And you can actually see the contacts going right there. And you can see it becoming a magnet. And then the contacts touch. And when they touch, the voltage is applied to whatever they're getting applied to, like a light bulb or something here. And I also can see this one. Looks pretty good too. That's all a relay is. It's such a simple thing. Now, bigger relays handle more current. The contacts on a relay, those little metal contacts right there, are specially treated metal, because you remember, every time you apply a current through wires, you're going to get a little bit of a spark. You're going to get a spark. So they have to be treated to be able to handle that spark. You know, after a million times, if this relay gets operated, you're going to have a million sparks. What's going to happen to those contacts after a million sparks, right? So they treat that metal specially. So the representation that we have here, when you actually look at the device, it looks like this box right here. So that's it. And there's a good one there with your hands. It shows a person's hand for what the relay is. So here's the basic need for a relay would maybe, let's say a little teeny amount of voltage here will turn this relay on. And when those contacts close over here, they can control something very big. Maybe a little tiny switch applying a small voltage to this relay coil, but will make these contacts close. And when those contacts close, they can operate something much larger and pull in a whole bunch of stuff to make it function and work. But yeah, so that's it. That should be it for relays. There's a real good picture of a relay right there. It really shows the contacts. Look at that. There's your coil. Look at that. How nice that is. And this one, look at this baby. Look at that. That was what it looks like when you take the top of this box off. See, this box is protecting the relay from being damaged. Because you could hurt that relay easy by banging. If you bang it with something, you could hurt it. So there's your terminals at the bottom. There's your terminals. And there's your coil of wire. Literally, that's just a coil of wire. You can see the wire right there wrapping around. So you can see how close this metal is to here. There's like a spring here. See that spring? And there's your contacts. Now note one thing important. If it's a single pole relay, you're only going to have one contact on it. But think about this now. If you notice this particular relay, there's a contact on the top and a contact on the bottom. So when this arm here gets pulled down, when this becomes a magnet, the relay contact will stop making contact on top with the top one, and it will go down and make contact on the bottom one. So two things happen. You have a break in the contacts and a make in the contacts. If that's what kind of relay it is. This is very, very common. These are everywhere in equipment. They're in your car. They're in all kinds of equipment. These are highly used in controlling stuff. Okay, that's plenty on relays. That's enough. Ning, ning, ning. All right, so that was a lot of fun. There's a lot of information there. But when you see those pictures, that shows you what it really looks like. And once you know the old saying, a picture is worth 1,000 words. Well, it is. And so what I've done is I've wired. I took away that other device, and I put in a laser generator. So we have our same scenario here. So let's go ahead and turn that on and take a look at this. So instead of our fireworks, now we have a laser generator. But still, all of this now is going through a relay. So the light bulb is still working, yes. So, I mean, really, this episode was really about relays, but I'm still going to call it Lightbulbs 103 because, hey, we're still lighting up a light bulb. I mean, how far can you go with a light bulb, right? I mean, there's so many things it can do. Also, an important thing to know about light bulbs is when Thomas Edison was trying to invent one way back when, he was trying to find the right materials to use for the filament inside of a light bulb. I think he ended up with tungsten and some other blends, but the most important thing was it has to be in a vacuum. So a light bulb is in a vacuum. They took all the air out of there. They sucked it all out with some machines, and then they sealed it. Because if it wasn't a vacuum, it would burn. That filament that glows would burn right up in the air. Important factor. Now, eventually, every light bulb will burn out eventually because the lifespan of that filament just wears out over time. I suppose if you lowered the voltage on it down to 100 or down to 90 volts, it would last longer, but it wouldn't be as bright. But for the price of a light bulb, it's not worth it. All right. So that should do it for this episode of 103 Light Bulbs. Light Bulbs 103. And I think we should end it on something interesting. What do you say? Let's change out our laser beam up here with, let's see, we get out of simulation and get rid of that, and let's just try putting in this disco light. This thing's big. What the heck? Let me revolve it around a little bit and see where the terminals are on it. I don't know. Let's put it there. Well, let's go to the 2D view and see where the terminals are. Oh, okay. We can wire that up easy. So let's go ahead and get we know what a ground is real good now, don't we? It's one side of the circuit. Wait a minute. Why is there must be a ground on it already? I don't know. How did that ground get there? I don't know. Let's go ahead and apply the wire to it and see if that makes any difference. See if it works. Because I don't know where that ground came from. No, it doesn't look like it's been wired, so we need to wire that up. But it automatically put the ground in. Huh. Or no. I'm wrong. I take that back. I'm wrong. The ground was already there because I put it there from before. Duh. Clear. All right. Let's get back to the 3D view and let's see what this thing can do. It's a disco light, huh? Let me I'm trying to back up here. All right, let's throw the switch and see what happens. Whoa, dude. Gnarly. It's gnarly, dude. Well, we're controlling a light bulb and a disco light from a relay. How cool is that? And how simple is that? Just a bunch of wires. All right, that should do it. You got the sissy here. We're going to sign off and see what happens next. I think I want to go into fuses next, because we got the relay here. We got the light bulb here. So I think the next one is going to be fuses. That ought to be cool. All right. Later. See ya.